what we have discussed in the previous class, right?
Yeah.
Okay, so we talked about 2D and 3D shapes, 2D and 3D figures basically, right? And what are the solid figures? We talked about them,
Yes.
right? And faces, vertex, edges, right? So these things also we
Yeah.
talked about. For example, if I were to give you example of a cube, right? So in a cube, how many faces are there? How many edges are there?
6 faces.
6 faces are there.
Yeah.
And edges, how many edges are there?
Yeah. 8.
No, it's more than 8 now.
12.
12. Right. So you have got 12 edges in it, right? Then what about vertex? How many vertex do you have in a cube?
8.
8, right? So you have got 8 vertex in a cube. Okay.
Yeah.
Then you have other examples of a sphere or cone. So if you were to have a sphere, simply let's take example of a football. So it has got only one face, right?
Yes.
While it does not have any vertex now. No
Yeah.
vertex, right? So basically it's a curve figure. So it has got only one face only, right? Okay.
Yes.
Now, if I were to make a figure here, on Arham and Arhan, see, let's see, this is a figure over here, and you guys are required to tell me how the top of this figure will look like. Let me complete the figure over here. Okay. Okay, so that is the given figure here. How the top of this figure is going to look like if you were to draw it on a piece of paper.
A rectangle. Yes, sir.
Yeah, a rectangle.
Yes.
With 3 divisions, no?
Yes, 3.
This one, and this one. Okay.
Yes.
Okay. Now we also talked about apart from cube and cuboid, we also talked about prism. Okay. So prism, we knew that it is a solid whose 2 faces, that basically base and top, are polygons, and side, that is the lateral faces, are parallelogram in this one. Look, whatever you guys must be aware of parallelograms, I'm hoping.
Yeah. It's slightly tilted. No, that's
Not necessarily slightly tilted. Parallelogram is a quadrilateral in which the opposite pair of sides are parallel and equal. They are parallel to each other. That means they will run indefinitely and never intersect each other, and they are also equal in measurement. Getting it, guys? 10 centimeter, 10 centimeter, 8 centimeter, 8 centimeter, for example. So that's a parallelogram. So see, for example, in this in this prism here. Okay, so here you are seeing that a prism is a solid whose 2 faces, basically the base and the top, are congruent polygons here. Getting it here?
Yes.
And the lateral faces are parallelogram here. Getting it here? So see this face here, if you guys are able to visualize this front face. Okay, imagine you are holding a piece of prism on your hand. Okay, so the lateral side which you are seeing here, getting it here, so that will be a parallelogram now.
Yes.
Okay, and one will be at the back of it, and one will be at the bottom. So there are in total 3 parallelograms we can conclude now, right?
Yes.
Okay, what about the faces? How many faces are in a prism?
Sir, 2.
No, they are prism is
5.
not. There are 5 now.
5.
These
Yes,
2 triangles
and 3 rectangles.
Not rectangles, parallelograms, it's better to say.
Parallelograms, yeah.
Right. So it's talking about its face, there are 5 faces in it. Talking about what we're talking about? Faces, right? Yeah. So it has got 5 faces. Talking about the vertex, how many vertex are going to be there? 1, 2, 3.
3 of 6.
Exactly, 6. Right. And what about the edges? How many edges are there in a prism, guys?
Say 6.
There are?
Yeah, 6.
6, no? Edges, no. What are you saying, guys?
3.
Edges. 1, 2, 3. Can you guys see it? 1, 2, 3, 4, 5, 6, 7,
Yes.
8,
9.
and 9, no?
Yeah.
So number of edges in this is 9. Yeah, Arhan and Aram. Okay.
Yes.
Okay. So here basically you saw that this is a triangular prism. Basically, our concept is not that prism can be of only triangular shape, right? That is the concept. But there are square shaped prism as well. So if you were to have a prism, basically take a cube. Let's say this is a cube here, right? So far we have been talking about triangular prism. Now let's talk about a square prism. Right. So in a square prism, what do we observe? We will see that it has got two parallel end faces, right? This face and the bottom one as well. These are parallel end faces. The base and top are going to be congruent squares here. Congruent, you guys know what is it. For example, I take two figures, right? Their area are equal. Their both area are equal, and they can overlap on each other. For example, my two palms, they are congruent, no? They can overlap each other. Getting it? So that is what we call as congruent figures. So in the case of a square prism, what do you see that the base and top are congruent squares and four lateral surfaces, each of which here is a square. Each of which will be a square here. I hope you guys can visualize it. Just imagine holding a piece of cube-like prism in your hand. Getting it?
A cube-like prism also like looks similar like a cuboid, right? Which is
Cuboid
like
is different now. Cuboid, the measurement of edges are different. But in a cube, the measurement of edges are same. Right? It's like you have got how many? 6 pieces of square sized keyboard cardboard, and you paste them, then you get a cube. So here you are having a square prism, right? The four lateral sides are also going to be equal. Getting it? Okay. So we basically say that square prism is a solid that has a polygon as its base and vertical sides perpendicular to the base. Can we not say that as well? Look here. I hope you guys don't get it to be very confusing. Look. So this is your prism. All right. And you see the base here. This is the base. This is the top.
Yeah.
Now talking about its vertical sides. What are the vertical sides? This now, this side, this side, this side, and the front side. These are like the vertical walls standing on the base. So they are perpendicular to the base. So these things which we are talking about, these are of general observation. There's nothing so much technical about it. I know. So if you guys were also to have a look at these figures, you will be able to understand it quite simply. Right? Okay. Okay, so then let's start our today's class. We will be revising some of the earlier concepts and we will be studying some new things also today. Okay. Right. So types of polyhedrons, we were talking it about in the previous class, right? So you have got regular polygons and you have got irregular polygons as well. So what are these regular and irregular polygons now? Look at over here. A regular polyhedron is made up of faces which are regular polygons. All the sides of this solid are equal. Such solids are also known as platonic solids. Interestingly, there are only 5 regular polygons. So can we have some examples of irregular regular polyhedrons from you guys?
A cube.
Cube, good. The point which prism. Yeah, prism. Okay. But it has to be of tetrahedron shape like this. Because if you were to look at the definition, what does it says here? It says that all the sides of the solid are equal. The sides have to be equal. I know. And
Yes.
and the faces are regular polygons. So what do you guys know about regular polygons? Regular polygons. Who will define this? Huh? What is a regular polygon? Anyone of you?
A shape with three or more edges.
No, that is different thing. Okay, that is simply example. That is simply definition of a polygon. But once we say that it's a regular polygon, what does it mean? If the measurement of sides are equal, then simply we can call it to be a regular polygon in this case. Getting it?
Yes.
Okay. So such solids are known as platonic solids, solids as well. No need to remember this term. Okay, just remember it to be regular polyhedrons in which the faces are regular polygons and all the sides are equal. Such solids are known as platonic solids as well. There are only 5 of them. Right. So here is one example of a polyhedron that we call as tetrahedron. Tetrahedron. Getting it?
Yes.
So count the number of, let's count the number of sides in it. How many sides are in it? 1. Basically edges we are talking about. 1,
Yes.
2, this front
4.
one, third,
Yeah.
and let's take this 4, 5,
5.
and this
Yes.
one 6.
Yes,
So
sir.
there are 6 edges in it, and all of them are going to be equal in measurement, right? So one more thing we can say that this tetrahedron is nothing but if you were to get 4 equilateral triangles, and you were to paste them, then you will get this tetrahedron. Know?
Yeah.
Okay. Okay. Also tell me how many vertex are going to be here in this
5.
particular figure. 5? No, I think you're mistaken. Look closely. Look closely. Or shall I draw the figure in this way? Look. Let's see now if you can answer more properly. Yeah. No. Can you guys have a better visualization now?
Sir, 8.
No, vertex I'm talking about. This 1, this 2, this 3, this 4 now. There are only 4 vertex here now. Vertex where basically the edges are basically meeting. Right. So this H1, 2, and 3 are meeting at this point now. I know.
Yes.
So this H6, this H5 and 1 are meeting at this point. So there are 3 vertex in this figure. Right.
Yes.
Okay. Like this tetrahedron, you could have yeah, sorry about that. You can have other examples as well. For example, you could have example of a octahedron. No. So octahedron, the diagram is pretty complex, but I will try to draw it. Okay, so it looks something like this one. Let's give it a try. Okay, it looks like this from here. Then you join it from over here. Then let's join it from over here. Yeah, and then further. I guess the diagram is not appropriate. Okay, just give me a moment. Like this from here. Now, can you guys understand the figure properly now?
Yes.
Yeah. Okay, and there's going to be one more line now from over here. Right now, I hope you can have a better visualization. So count the number. Exactly. Basically, you have taken 2 pyramids and then you have joined them. So that is basically an octahedron. So octahedron, why would this going to be one more line, guys? This one. at the back. Okay.
Yeah.
So in this figure, you will seeing that they basically 4 equilateral triangles, not 4, 8 equilateral triangles have been combined.
Yes.
Octahedron, you've got 8 equilateral triangles. So count the number of vertex in it.
Sir, 6.
Vertex equals to 1. Let me mark them. Okay, you said
Yeah,
6.
6.
1, 2, 3, 4, 5, 6. Very good. So there are 6 vertex in it. Now count the number of
Yes.
faces in it. How many faces are there?
Sir, 3.
8.
Sir, 7.
Okay, how much, Ahmed?
3.
No, faces now.
It's
Look,
8.
since it's going to be 8, why? Because we
Yes, sir.
have got, simply you have taken 8 equilateral triangles, right?
Yes.
And simply
That's
take
why it's octa.
exactly, that's why the name is octa. So faces are 8 over here. Getting it?
Yes.
Okay. Now, what are some other examples of regular polyhedrons apart from the tetrahedron and octahedron? You have got dodecahedron and icosahedron, right? So these are pretty bigger figures where the dodecahedron has got 12 faces, right? And here you have got 20 faces. So in dodecahedron, you will see that all the faces are regular pentagons, right?
Yes.
So that will somewhat look like this. That will be a pretty more complicated diagram, which won't be possible to draw over here. Okay. So, but
Okay.
still, if you were to see the phases of a football, that will somewhat give you similar picture. Okay. So see the phases of a football. They are somewhat like this, right? And all of them are joined together.
Yes,
It's
sir.
like 12 pentagons.
Exactly. So you will be having 12 pentagons, and basically you stick them together and you will be getting a shape of dodecahedron. Then if you were to
Yeah.
get 20, if you were to get a regular icosahedron, in this you will be having 20 equilateral triangles, guys. I know.
Yes.
Okay then. Any confusion so far?
No.
No, sir.
Okay. Just remember the number of faces in them, right? That
Yeah.
is pretty that is important. And a tetrahedron is made up of equilateral triangles, while a cube is made up of basically squares. You guys already have
Squares.
studied this one. And regular
Yes.
octahedron has got how many equilateral triangles?
8.
8 equilateral
8.
triangles. So the number of faces and the number of polygons is same here. Get this thing. That is
Yeah.
pretty simple here. Okay, for
Yes.
tetrahedron has 4 face and it had 4 triangles. Cube has 6 face, 6 squares. Regular octahedron 8 faces, meaning 8 8 equilateral triangles. And
Yes.
dodecahedron and icosahedron that we discussed here. Okay, now moving on, let's talk about what are the irregular polygons. So what
Yeah.
do you mean by an irregular polygon here? So
Sir, which
here
side are not equal?
the sides are not going to be equal. In fact, the
Equal, yeah.
polygons are not going to be of equal shape. The polygons are going to be different here, right? So their shapes will also vary. So if
Yeah.
their shape will vary, it means the sides of the irregular polyhedron are not equal, right? So
Yes.
for example, a prism. Moments ago we talked about prism now. So here in the prism, are all the sides equal, guys?
No.
No,
Ahmed,
sir.
Arhan, Ahmed, no, obviously it's no. No.
Yeah.
Okay. So that is one example. Apart from this, you can have other examples as well. Okay. For example, if I were to draw a figure like this. Okay. So imagine it's a 3D figure. Imagine that it's a 3D figure, but does it look like a regular polyhedron?
No.
Sir.
Obviously no, right? Because sides have got different measurements here, right? Okay.
In a polyhedron, all the sides are equal and they meet at the edge.
Yeah.
In a polyhedron, all the sides are equal and they meet at the edge.
Exactly. All the sides are going to be equal. Okay. And all the
Yes.
polygons are regular polygons and they meet at edges and they form proper
Yes.
vertices in them. Getting it? Okay.
Yeah.
Now, moving on, we also talked about other types of polyhedrons, right? Based on the diagonals also. I know. For example, we talked about convex polygons and concave polygons, right?
Concave. Yeah.
So when do we call a polyhedron as convex polyhedron? Hmm. Let's say if
We
you have
call
got, Mhm,
it a convex polyhedron when we
mhm,
draw a line from one vertex to another vertex and the line gets inside the figure. So it's called a
mhm.
convex polyhedron.
Exactly. So for example, in this cube, you see, you draw a line from two vertex and they are meeting inside the figure, right?
Yes.
While if I were to have another figure like this, okay, let's imagine that it's a 3D figure. Okay. And in this case, if you were to draw line from two opposite diagonals or line from two basically, if you were to draw line from two vertices here, for example, this one and
Yes.
this one, they will be meeting but outside the figure. So that was an example
Yeah.
of a concave
Concave
polyhedron.
polyhedron. Yes.
Yeah. So considering some of the examples of convex polygons, you have got example of what? Cube. You have got example of cuboid. Then you have got example of prism now, right?
Yes.
And pyramid as well.
Yeah.
Okay. In today's class, we will also get to know about the difference between prism and pyramid and what are the similarities. Okay. For example, one usual observation you will see in the case of um pyramid, you will see the base.
Yes.
Okay. And in the case of the prism, you will see the lateral surfaces, they are varying. When we will come to that topic, we will have a better picture of that. Okay. So far, what we have discussed, let me quickly summarize it. In the chapter, we have talked about, okay, why is not erasing? Okay, let's see if I have got enough space over here. Okay. So far in the chapter, we talked about 2D surfaces, we have talked about 3D surfaces, and we have talked about their faces, about their edges, and about their vertices as well. Okay, and then we also looked at some of the general formulas that might help us, not in this chapter, but in other chapters that will be helping you. Okay, so for example, we talked about curved surface area. We talked about
Yes.
total surface area of some of the basic solid shapes like cube, cuboid, right? A
Cylinder.
prism, right? A cylinder. So we have talked about that. Although that thing, no, you guys have to study in the mensuration chapter.
Mensuration. Yeah.
Okay, so don't worry about the formulas right now. Okay, and then we talked about the types of polyhedrons. Polyhedron, do you guys know about this concept or not? Like, we have been talking about polyhedron, but what is it a polyhedron actually is?
A figure with more than or equal to four faces, which meet at a edge.
Exactly. That is a polyhedron, right? So basically, you have got
Yes.
different polygons, okay, and you join them together, you get a polyhedron. Okay.
Yeah.
Okay, but the polyhedron could be regular and irregular as well, right? So
Yes.
right now, what we were talking about, that whether it could be regular or irregular, it was decided on the type of polygons of which they are made up of,
Yes.
right, guys? Or we say, let's say, faces. So the first criteria we have talked about so far is the on their faces. Getting it? So if the faces, that is basically the polygons, right now. So if the polygons are regular shape, then it's going to be regular polygon. If the polygons are not irregular, then it's going to be irregular polygon. Okay.
Yes.
And one more thing I think we have discussed that in the previous class, That second classification we have discussed at based on diagonals. Right now. So if the diagonals were to meet inside the figure, then we were calling them as convex polyhedron.
Convex. Yes.
Yeah. And if the diagonals were meeting outside the figure, then we call them as
Concave.
concave polyhedron. Getting it, guys?
Yes.
Okay. Ahmed, Arhan, and Arham, to both, to all you guys, is it clear so far?
Yes, sir.
Yeah.
Hmm.
Okay. Okay. Ahmed, are the things getting confusing here? Because we had already started the chapter in the previous class, and you have joined a bit late.
Yes, sir, it is.
Okay. Don't worry, but we will still be covering that, and hopefully it will get clear to you as well. Like the basic things now, you guys already know what are 2D shapes. In a
Yes.
2D figure, you have got only length and breadth, right? So, for example, if you get a piece of A4 sheet paper, that is a 2D figure, right?
Yeah.
But let's say if you have got 100 pieces of 2D, 100 pieces of A4 sheet paper, and you pile them, right? You pile them like this.
Yeah. We get
So
length, breadth, and height.
exactly. So you have got a thickness as well now. Ahmed, you have got a thickness here as well that we called as height. So whenever you have got a 2D shape, you can convert it into 3D shape by thickening the object. Getting it, Ahmed? Okay.
Yes, sir.
Okay. And the solid shapes we are talking about here is basically they are also they can be also called as polyhedrons. So polyhedrons are what? So you get different types of polygons, right? For example, a pentagon, for example, a triangle, for example, a square, or example, a rectangle, and you paste them, you combine them together, then you end up getting a polyhedron. Okay.
Yeah.
So that we are talking about here. For example, if you have got a piece of dice in your hand, that is an example of polyhedron. If you have got a cuboidal shape, okay, that is an example of a polyhedron. You have got a pyramid shape structure. You have got a prism shape structure. These are all examples of polyhedrons, right?
Got it, sir.
And based on the type of their faces and based on the type of their diagonals, we are classifying them here. So the first classification, we talked about their faces. Okay, so based on their faces, they are regular, and then they are irregular polyhedrons as well. For example, prism, we talked about it. Getting it? Okay. Then the next thing we talked about is the based on their diagonals, where their diagonals are meeting. So you were to draw a line from opposite vertex. If they meet inside the polygon, inside the polyhedron, sorry, then it is called convex. Otherwise, it will be called as concave. Now, quickly moving on to next concept. On the number of faces, not type of faces. How do we classify them? So you guys have already studied like on the number of faces. How do we classify polygons? You had triangles, quadrilaterals, pentagons, hexagons. Now
Yes.
you had 2D shapes like these. Now we were having 2D shapes like this. Okay. So this was called as quadrilateral, this was called as triangle, this was pentagon, this was hexagon. Now here we have got 3D figures. We are talking about 3D figures, not 2D figures. So 3D figures, based on the number of faces they have got, we classify them as pentahedron, heptahedron, nonahedron, decahedron. Getting it over here? So suppose if a
Yes.
figure has got 5 faces, so what do we call them as? Polyhedron. Oh, sorry, pentahedron. Right?
Yes, sir.
Yeah.
Okay. Now the thing is, you guys should have asked me why the possible number of figures shouldn't be possible number of faces can't be 4. Because imagine, is it possible?
Yes, sir.
Okay, will it be possible to get a pentahedron with 4 faces only?
No, sir.
No, sir.
No. Why
Yes,
not?
sir. It should be
It will be.
equal or
It will be.
more than 4.
Mhm. It will be equal and more than 4, no? Take an
Yes.
example of this figure, no? Take an example of this figure over here. How many shapes do you, how many faces do you think this one has?
Which
This figure over here.
um
There are actually 3 figures here, no?
4.
Yes, sir.
No, sorry, 4 faces here, no?
Yeah.
Okay, so imagine we were talking about tetrahedron a while ago, no?
Yes, sir.
Yes.
Okay, so if the polyhedron has got 4 faces, it will be called as tetrahedron. If it has got 7, 9, 8, 7, 9, 10, 5, and they will be called as follows, as mentioned over here.
Polyhedron. Yeah.
Okay. Okay, now let's move ahead then. Now, based on presence of diagonal, we have already discussed this one. They will be convex polyhedron and non-convex, or also called as concave polyhedron.
Yes.
Okay, let's skip this one. We have discussed this one already. Now, let's talk about some of special types of polyhedrons. Okay, for example, you have got example of a prism here. Okay, so what are the features which we can see in a prism? Moments ago we talked about it. Okay, moments ago we talked about it. It is a solid whose 2 faces, that is base
Sir,
and top, are
its
congruent
3
polygon.
faces are parallelogram.
Exactly. 3 of the faces are parallelograms. Obviously,
Yeah.
the side faces,
Yes.
right? And the top and bottom faces of the prisms are triangles, which are basically
Yes.
parallel
triangles.
to each other. No. Okay,
Yes.
let's draw a vertical
Yes,
figure
sir.
of a prism over here. Well, it's going to look like this. Right. So this face and this face, they are going to be parallel to each other. Getting it? Okay, now talking about pyramid. What is a pyramid, huh? So pyramid of Giza, you guys must have seen in movies, in YouTube's. Yeah, it is a solid whose base is a polygon here, and lateral faces are triangles, and they have got a common vertex. I know. Getting it over here.
Yes, sir.
Okay. So who will explain the figure to me? Okay. What should I draw first? How do you draw a pyramid?
And we draw 2 triangles, and then from the inside we draw a line, and then also a triangle.
Okay. That is a pyramid.
Pyramid. Yeah.
Okay. So look over here. Pyramid is drawn like this. Getting it over here.
Yes.
That is basically the figure of a pyramid. The base is actually not a rectangle. It's a quadrilateral, right? And
Yes.
it's not necessary that it's going to be a cube or a square or a rectangular shape. Getting it?
It's a parallelogram, right?
Yeah, it's a parallelogram. It might be other might be the it might be that the sides are equal, or they might also be unequal as well. Okay.
Yes.
Okay. Now talking about the similarities between a prism and pyramid. What are the similarities between the two figures? Like both of them are 3D figures,
Yes.
right? All the
Yes,
sides
sir.
of the prism and pyramid meet at the bases. So whether if you were to draw a prism or whether you were to draw a pyramid.
So can we write one more point that it has 2 triangles? Their faces are 2 triangles.
Yes, obviously we can add that one. It has got 2 triangles in it. In fact, 2 equilateral triangles. Getting it?
Yes.
Why
Yes,
equilateral triangles? Because
Because
since they are parallelogram.
parallel, yeah. They
exactly,
are parallel
exactly,
to each other.
exactly. That is the reason. And here you get 4 triangles. Right. Okay.
Yes.
Now talking about other things in this one, the sides are not round. Obviously, they are sharp edges. They have got sharp edges. Okay, and they have got flat bases. Right. This is the flat base. Okay, this one is also a flat base. Okay, that is
Yes.
pretty simple over here. Now, what is the next thing that we're going to talk about here? Like if you are provided with a geometrical figure, and if you were to ask the number of faces in it, or either the question is to find the number of edges in it, how do we do that? In order to understand this one, let's have a look at look at an example over here, which I'm going to draw over here. Okay, so let's say that you have got a cuboid. Then let's say you have got a cube. Okay, so all right. Now, number of faces in it. How many faces are in both of them? To tell me.
So in which?
In cuboid.
In both of them.
In cuboid 6.
Number
And
of
also cube
vertex.
also 6.
Yeah, number of vertex.
Yes, sir.
Number
8.
of vertex in both of them. 8. So
Yes,
this
sir.
is 6, 8 and 8. And number of
8,
edges
yeah.
in both of them.
12.
Number of edges are 12.
Yes.
Right.
Yes.
Ahmed, Arhan and Arham. Right. So number of edges are given over here. Now,
Yes.
if I were to represent like this, let's say it to be by capital F, I'm representing it by capital V and capital E. Okay. Now, here you will see that let's add the two faces and number of vertex. So it will be 6 plus 8 here, that is
8,
equal to 14. Right.
Yes.
Now, take the number of edges. Okay, and add 2 to it. So the number of edges are 12. 12 plus 2, that is equal to 14.
Yes.
Okay, just keep looking at it. Now, can we see that F plus V is equal to E plus 2 over here? Can we say this here?
Yes.
F plus V and E plus 2? Yeah?
Yes.
That
Yes,
is
sir.
equal now. Okay, so okay, now you guys check this same thing for other polyhedrons. For example, if I give you a triangular prism. Okay, now write the number of faces, vertex in them, add them as I have added them, and see if F plus V is equal to E plus 2. Okay.
Yes.
Okay, let me draw the figure to help you guys here. So triangular prism, how does
Only
it
a
look like?
triangular prism, right?
Yeah.
Only a
It's
triangular prism, right?
Only a triangular prism, yeah. Okay, so do this one. Triangular prism, you guys already know this, no? I don't think there's any need to draw it. But still, let me draw it. Yeah. Okay, basically you guys are required to check if the relation is
Sir,
true.
9 in this.
9. Okay, no need to answer it. Okay, just check if the relation is true for this figure as well or not. Okay. Okay, Ahmed, are you getting it?
Not really, sir. Confusing.
Okay, look here now. Basically, the basic idea of a solid figure, it must be having some amount of faces now. If it must be having a face, it must be having vertex now. And it must be having some edges. Do tell me one thing, that are you familiar with the three terms or not? Face, vertex, and edges.
Let me repeat that 3 words again.
Here I've written them: face, vertex, and edge.
Yes.
That you know.
Yes, sir, I am.
Oh,
Face
है ना?
vertex.
So if you were to be holding a piece of dice on your hand, okay, so how many faces does a dice have?
Sir, I got. Shall I say in the chat box?
Yeah, just send in the chat box by either writing yes or no. Okay.
Hmm.
So you see Ahmed here.
Five.
This cube here has got how many faces? Just imagine you are holding this piece of cube on your hand. Yeah, Arham, that is correct. Very good. So if you were to be holding that, you will see there are going to be 6 now.
Yes, sir.
6. Did you see it 6? So you will see that it will be having 6 faces. Now vertex, you all are aware that it is basically the point where all the lines meet.
And
So
okay.
this line and this line are meeting at this point. Similarly, so
Yes.
likewise, there are how many of them? One here, one here. Basically, we are not talking about the corners.
Eight.
Getting it? So there are 8 vertex in it. Now edges, what are they? Yeah, Arhan, that is correct. Good. So edges, what are they? Edges are basically side now.
Yes.
This one side, this two side, this one side. No. These are basically the edges. So if you were to count them, there are how many? You will see there are 12 edges in this, right? So in the Euler's formula, you will see that if we know the number of faces, the number of vertex of the given polyhedron, we can find out the number of edges using the polyhedron formula or Euler's formula.
Yes.
So that is the formula here. That is, if number of faces plus number of vertex is equal to E plus 2, then it can be written as face plus vertex minus edges equal to 2.
Yes.
So simply, it's you are provided with any two values, third value can be find out.
Yes.
Yeah. Okay. So we have now Ahmed represented them as F here, the vertex as V and edges as E. And basically we have put the values here like the 6, 8 and edge here, 12 here. So if you were to add the number of faces and vertex, you were getting 14. And if you were to add 2 to the number of edges, you were getting 14. So relation is 2. Both of them are correct here. No? I mean, both of them are equal here.
Yes.
Right. So solve a question here. Take this example here. The number of faces for a polyhedron with 5 vertex and 9 edges. So here vertex, that is V, is given, edge is given. We are required to find the number of faces, that is F equals to how much. So you guys are already aware that what is the formula. Formula is basically, F plus V equals to E plus 2.
Yes.
Right. That is the relation, and that can be written otherwise as well. Right. Like this, F plus V minus E equals to 2. F
Sir,
plus
another answer can I say?
F plus V minus E is equal to 2.
Yes.
It can be written like this as well. Basically, we have made the constant value on the other side of the equation.
Yes.
We have written 2 over here. So this
First
is
we add
basically
the
Euler's
edges.
formula.
We do edges plus 2, and then we transpose the
E from
the
here to here.
faces. Yes. We have to find the faces, right?
You have to find the number of faces.
So we transpose the faces and then we subtract it.
Here this example has already been done. I will give you guys one more question to practice on this. Okay.
Yes.
Okay, good. So here basically you see F plus V equals to 9 plus 2. Edges is given. There are 9 edges in it. Looking at the question. Okay. Vertex, you guys know it is 5 in the question given.
Yes.
We need to find what is the number of faces. So F plus V equals to E plus 2. Right. So we say F plus 5 equals to 9 plus 2. Anna Ahmed?
Yes.
So it's F plus 5 equals to 11, or F is equal to 11 minus 5, that is 6. So that is pretty simple here now. So if the figure has got had got 6 faces, so the what is the probability of the polyhedron? What polyhedron is it? Is it a cube, cuboid, triangular prism, square pyramid, or triangular
It's a
pyramid?
triangular prism.
Yes, sir.
Not a triangular prism. What are you guys saying here? Guys, which polyhedrons
Yeah,
have got
no.
6 faces?
so,
Look, in a
sir,
triangular prism, how many faces we had? Ahmed, Arhan,
Um,
and Arham. If you guys were to look at it, this
5
one face,
faces.
this one face, this one at the back side, and this bottom one. There were 5 faces
Yes.
in this one. No,
sir, 6.
Yes.
five faces are over here. So you have example of cube and cuboid. No, those are the polyhedrons where you have got 6 faces. Okay, I'm giving you guys
Yeah.
one more question. Okay. Okay, next question which I'm giving to you guys is, let's say the number of, okay, let me see it, find the number of faces for a polyhedron with, let's say the number of vertex is going to be with 4 vertex, okay, and 6 edges. Find it out using this formula, f plus v equals to e plus 2. No, that is wrong. In fact, if you were to imagine, is it possible to get a polyhedron in which there are only 2 faces? Suppose I give you
No,
2
sir.
pieces of cardboard and I ask you to make a 3D
No,
figure.
sir.
That is not possible without
So it's
breaking
4.
them.
It's 4.
Whatever the answer is, it might be 4, 6, 7. We don't know yet. Okay, just solve it and give your answers in the chat box. All right. Okay, Ahmed, is it getting clear now? Huh?
Yes, sir. Do I have to use the formula f plus v equals to e plus 2?
Yeah, exactly. You have to read this, take this formula. Right.
Okay, sir. Understood.
Or no, it can be written otherwise as well. Okay, or you can use this one as well.
Sir, 4.
Arhan, okay. Okay, guys. So most of you have answered. That is correct here. But you guys now need to answer it in the chat box once I have
Sorry, sir,
said.
I did not listen to that.
Okay. Anyways. Okay. Arhan and Arham, both of you have answered. Let me see the answer. 4. Yeah. Arham. Okay, 4. Yeah, that is correct here. Okay.
Yes.
Good. So f plus v equals to e plus 2. Right. The values are given here. F plus vertex. How many vertex are there? 4. Okay, it's going to be 6 plus 2 over here. So f equals to 8 minus 4. That is 4. Okay, good.
4.
Right. So that is basically the Euler's formula. And in the upcoming exercise, you will be required to solve it. Right.
Yes.
Okay. Okay, now one more question. Let's solve one more question. Let's say if the number of vertex is 6, number of edges are 12. Find the number of faces.
Okay, sir.
Percent. Sir, I've sent.
Yeah, I'm looking at it. Yeah, that is correct. Very good. That is correct. Good. Okay, that is the required answer. Okay, all you guys have answered it correct. Good. Now look at exercise 10.2. What you guys have to do in this one. Okay, the first exercise, Arhan, you have also solved the first exercise, right?
He said it's almost done.
Almost. Why
Yes.
almost? That should have
So
been done
since,
completely.
Sir, since I have to go somewhere, that's why.
Okay, no issue. Okay, although that's a very simple exercise, right? Okay,
sir.
so exercise 10.2 shows you that you have got figure. Basically, you have given map of a city over here, right? And you have to answer the following
The
here. Like the
questions.
color the map as follows: blue water, red fire station, orange as the library has to be colored as orange, schools has to be colored as yellow. So that is basically a bit of painting going on here. You have to basically paint them,
Yes.
right? So
Yeah.
nothing mathematical in this. Now, question number B, mark a green X at the intersection of Road C and Nehru Road. So where do you see Road C here? Mhm. See Road C, where is it here?
Primary school, near the primary school and the locality.
Road C, this one over here, no? Yeah.
Yes.
Yes, sir.
Okay, and further it says that you mark a green X at the intersection of Road C and Nehru Road. This is on Nehru Road over here. So they are
Yes.
intersecting over here, no? This, right?
Yes,
So
Yeah.
we will mark a green X at the intersection of the two here. Getting it?
Yes.
yes, sir.
Okay. Then see the next question. What does it says? Green Y. In the same question, green Y at the intersection of Gandhi Road and Road A. So
Sir, road
Road
is
A is here.
near library.
Here near library. And this is
Hmm.
your Gandhi Road, no? So
Yeah.
here it has to be marked. Right.
Yes.
Okay, that is simple. Now question number 2 that you have to do yourself. Draw a map of your classroom using proper scale and symbols of different objects. So you guys can do it. Yeah.
Yes, sir.
Okay. So that can be performed by yourself. Now the third one, draw a map of your school compound using proper scale and symbols for various features like playground, main building, etc. The fourth one, draw a map giving instruction to your friend so that she teaches you how without any difficulty. So these are basically pretty simple questions, and that can be performed by you guys as well. Okay.
Yes.
Yes, sir.
Good. Here your houses. Here your what? Yeah. Here, let's say your friend lives here, right? So the direction you have to basically make, and in the path, what are the buildings and what are the structures that follows there.
Yes.
Getting it?
Yeah.
Now, moving on to exercise 10.3. The first question says that can a polyhedron have for its faces, can it have 3 triangles, 4 triangles, or a square and 4 triangles? The first one is obvious. I am expecting the answer from both 3 of you. As we have discussed, the minimum number of possible faces is how much?
Sir, 3.
Oh.
6. 6.
6. No, you have got 4, not tetrahedron. Ahmed, do you remember
So 12.
tetrahedron?
So 12.
Where are you? 12? No. A polyhedron will have minimum of 4 faces.
Yes,
Guys,
sir.
look at the example. Moments ago, we have talked about it. This tetrahedron, as I said, a polyhedron with 4 faces.
Yes.
This was the required figure. Huh? This
Yes.
one face, this
Yes,
second
sir.
face, and one face at the back, which I can't draw it properly here. Let's imagine it to be the back figure. And the base now.
Yes.
Yeah. So there were minimum 4 faces possible in a polyhedron. Okay, Ahmed,
Yes.
Arhan, and Arham.
Yes, sir.
Okay. So whenever you are now solving the exercises on a plain sheet of A4 sheet paper, just draw all the different types of polyhedrons. So that
But
will
it
help
says
you.
3 triangles, right? So 4 3s are 12, right?
4 3s are no. You are talking about faces now. We are not talking about
But it
side.
says for 3 triangles.
Can a polyhedron have for its faces 3 triangles? No, such polyhedrons are not possible. Now, a polyhedron should have a minimum of 4 faces.
Yes.
Look at the question carefully. It says that can a polyhedron have for its faces 3 triangles? No. Right. Now, talking about 4 triangles, that is possible. Right.
Yes.
And the name of the polyhedron is tetrahedron.
Tetrahedron.
Yes, sir.
Right. Okay. And a square and 4 triangles, is it possible? Exactly, that is possible, no?
Yes,
Remember
sir.
Yes, that is.
about
Hmm.
okay, I'm expecting answer from you guys. Name the polyhedron possible, which can have a square and 4 triangles. Imagine you are in Egypt.
The
Sir,
Which
pyramid.
figure?
pyramid.
Pyramid. Very good. Okay. Question number 3. Which are prisms among the following? Yeah.
Sir, unsharpened pencil.
Which one?
Sir,
A
second
sharpened
one.
pencil.
Yes, sir.
Unsharpened pencil. That is a
Yes,
prism.
yes, sir.
Okay, good. Then
A nail.
a nail. No, no, no. A nail. It is not a
No, sir.
prism here.
Yes, sir.
Because here you see a prism does not have a curved surface. Now the
Sir, it's a
surface is
cube.
curved here. It's a
A
cube here.
box.
This box here,
A box.
and
Yes.
this table weight as well.
It has
It is
two
also a
parallel
prism.
squares.
Hmm. The base and top are parallel here, and this
Hmm.
one here, right?
Yes.
Okay, right. Now, question number 5: is a square prism same as a cube? Explain this one.
Mm, no, sir.
No
Yes, sir.
or yes?
Yes.
Okay, moving on to the first question. There was question number 4 as well. How are prisms and cylinders alike? How a prism and cylinder alike? The question here is that. Look, a
Sir, since
cylinder.
it have
Mhm.
3 parallelograms. Since
And
it have
two
parallelograms.
parallel surfaces.
Yes, sir.
Okay, look, the thing here is now a cylinder can look like a circular prism, a prism with a circular base.
Yes.
That is the reason a prism and cylinder can be alike.
Yes.
So, but
That is the
prisms
reason.
do not have a circular shape, right?
No, but there's a distinction which we are seeing here. If you were to look at the example of nail earlier, this nail here, why this nail was not a prism here? Okay, so what do we see in this?
So,
There are
since
no parallel.
is
No, look at over here. This is the surface of the nail, and this is the head here, right? So you are seeing here one thing, guys, that the edges are not in contact with each other. The edges of this head,
Yes.
the edge of this head and this long surface, they are not
Not a
in contact with
tetrahedron.
each other. Not example of
Yes.
tetrahedron, guys, but imagine you're holding a piece of nail on your hand and see their head. Are the surfaces in contact with each other? Are the edge in
No.
contact with the edge of this
The
one?
edges aren't.
They are not covered properly. So that was not example of a
Yes.
prism. Okay. And while talking about a cylinder, okay, a cylinder can look like a prism with a circular base. Getting it over here.
Yes. Yeah.
That is the distinction. Okay, so solve as many questions as you guys can solve in exercise 10.2 and 10.3. Getting it?
So do we
Okay.
have to send the 10.2 exercise?
No, 10.2. No, in this one, you have to solve only this one.
It's just
Question
drawing.
number B. Okay. And question number C, D, and E as well.
Okay.
Getting it? Okay, just
Yes.
draw it on a piece of paper. No need to color it.
Yeah.
Okay, then. Okay, so that's it for today. We will meet in next lesson. Okay, and Ahmed, you can do one thing now. Yeah, Ahmed.
Yes.
Okay.
Yes, sir.
In the next class, you can in the next mathematics class, you can join 5 or 10 minutes earlier, so that whatever has been left in the chapter, we can discuss that for you. Okay.
Yes, sir. But I have a issue, sir.
Yeah. What is? Yeah.
It's a Wi-Fi issue, sir.
Okay. Okay. So is that the reason you haven't been able to continue the classes? Like you were absent for a while.
Yes, sir. 2 or 3 weeks.
Yeah. Okay. 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 We will see what can be done. All right.
Yes, sir.
So is the
Okay,
chapter
guys. Then.
finished?
No, the chapter hasn't been finished yet. Because exercise 10.3, once you guys
3
will
is
do
remaining.
this, then it will